Our second setup will be for our code blinker key. First we will build the code blinker key on a breadboard, like this. Just build it as shown here. Keep in mind to use the right resistors on the right places. For this board here, do note that you have to place it with the USB connector to the outside. This small board you see here is actually an Arduino. It is called an Arduino Nano and has the same functionality as the Arduino Uno, but it is smaller. Furthermore, there are two new components we are using. This one is called a button or switch. When you don't press it, the circuit will be broken on that place. When you press it, the circuit will be made. You could replace it by a wire as shown here. See the video on buttons for more information. The LED is a somewhat more complicated component, but you only have to know that it will emit light, and that the LED has a polarity, which means that there is one leg, which is a plus, and the other leg should be connected to the ground. So try to test the button now. It is attached to the LED. When you press the button, the LED will light up. But we want to control the LED with the Arduino, so let's change the setup so we can do that. LED stands for light emitting diode, so it's actually a diode, which emits light. But what is a diode? That's a component that blocks all the current going to one direction. So this is also the reason it has a polarity. Like this, the LED will shine, and if you place the LED like this, no current will flow at all. But when there is current, we don't want it to be too much, because that could damage the LED. So therefore, we use a resistor. This is a 300 ohm resistor, and to know if it's enough, you can use Ohm's law to calculate the current. You need to know that LEDs has a typical maximum current of 20 milliamperes. You can find this in a datasheet or by googling it. So let's see if this resistor is enough. We have a 5 volt voltage from the pin we are going to use at max. No Arduino gives more than 5 volts from a pin. Ohm's law say for a current is voltage divided by resistance. If we put a 5 volt there with a 300 ohm resistance, we get 5 divided by 300, which is about 17 milliamperes. And that's safe. Also, more accurate should be to actually take the voltage drop over the LED into account, which is about 2 volts. This will only lower the actual current, actually by 40%. So we're certainly safe with 300 ohms resistors. And there's also a 300 ohm resistor in the button circuit. It has the same functionality as for the LED. However, there's a second resistor of 15 kilo ohms. Without this one, it could be that you would measure all kinds of weird signals. Without attachment to a ground, it doesn't have a ground. So the charge on the wire cannot go anywhere and will disrupt your measurement. This resistor may be really big. Everything above the 10 kilo ohms will be good. So remember this when your measurements show all kinds of weird values. Now the hardware is set up, let's continue to the software. So here's the flowchart we made earlier. I don't think we have to make it more specific. So open a new project in Arduino IDE. First define the pins here. Then we think of the code and put it into an array. An array is a list of variables. And like this, you can access the first variable in the list. And like this, the second, and so on. Don't forget it starts at a 0 and not at a 1. Zeros and ones make up the code. If it's a 1, we want to send light, and if it's a 0, we don't want to send light. Then in the setup say the LED pin is an output and the button pin is an input, just like this. Also, don't forget to put comments wherever you want. Then, in the loop, we want to send a code when the button is pressed. The diamonds used in the flowchart indicate an if statement. So we make an if statement for this, and it is checking if the button is pressed. So let's measure the button pin like this. Put the measurement in a variable. We use this in the if statement. Here we use equal, bigger than, smaller than, or not equal to. Those are Boolean operations, which will return as 1 if it's true and a 0 if it's false. So with an equal sign, we put a value in a variable. With a double equal sign, we control if the value is equal. Also, the Boolean can be used just like we use the integers. You only have to use bool or Boolean instead of the int. If you want to get more knowledge on the Boolean operations, watch the video about Booleans. Now we have the first part of what we need. Now let's make the LED blink. We can make it blink like in the blink example. Open the example again and copy what you need from it. Just the digital write, and we want to use the delay too. Place this in the if statement. Now we can already test the code, so upload it. But wait, you will have to change the board type, otherwise it's not going to work. Go to Tools and check if the right port and the right board type is selected. Just like this. Now try to upload it. If it still doesn't upload, check if it works when you select a different processor in the Tools and then Processor. Or control what the debugger says and maybe you made a mistake somewhere. If you press the button now, the LED should light up just like earlier. But we wanted to show a sequence. Therefore, we have to improve the code. We can easily do it by copying this part like 3 times and choose the value in the array to decide if the send signal is high or should be low. Just like this. Also, we don't want the delay to be 1 second. It's way too long. I think 25 milliseconds is long enough. Let's make this a global constant, so we can change it later on easily. Now you upload the code, you will see that it actually works pretty well. But writing code like this is not a good practice. You want it to be maintainable and therefore more compact and more universal, so that it still works if you use longer codes, for example. Actually, that's what we want. Now we have 3 values in our code. I actually want to have 7. Now you probably see, using this method is not optimal. Therefore, we are going to change this into a for loop. For loops can execute code several times in a row. And that's exactly what we need. We are doing here 7 times the same code, only with a different value read from the array. So let's make a for loop. You start like this. This is the counting variable. It will start at 0. This is the condition it should run. We want it to run 7 times. And this is how the variable we just made should change each loop. We want it to increase by 1 every time. Now place the digital read in this loop and change the 1 to the value of the array. And don't forget to put off the LED after the loop. If you upload it now, you'll see it still works. And that's it for the blinky key for now. Let's test it in combination with the base station.